Hello, welcome back. Let's talk about integers. Now, integers are positive and negative whole numbers. What's a whole number? The counting numbers, starting at 0, 0, 1, 2, 3. Take those and the negatives, you get integers. It's good practice to visualize the number line. You're dealing with integers. Here's 0, it's like the midpoint, if you will, of these numbers. They go up 1, 2, 3, 4. That's your whole numbers, or your natural numbers, your counting numbers up. And then you got your negatives going to the left. When in doubt, draw a number line. And eventually you'll just be able to visualize this. So where are integers used? Most commonly, you've probably seen used in temperature. Positive above and below 0 degrees Fahrenheit or Celsius for that matter. Altitude, above or below sea level, where you could often consider 0 to be at sea level. And also maybe when you're talking about money, you're talking about being in the hole or being in the red, that's negative, whereas in the black is positive. So let's talk about adding integers and how that differs and how it's the same as adding whole numbers. So let's look at something we already know. 2 plus 3, that's 5. It helps to think about these numbers as on the number line. There's 2 and there's 3. And they're both on this side of 0, on the right side of 0. They're both positive. So it shouldn't come as any surprise that they kind of work together on the right side of 0. And so you just add the two numbers together, and your answer is still going to be positive. What if they're both negative? Well, now they're on the left side. Negative 2 and negative 3 are here on the left side of 0. They're still working together on the left side. You can imagine like whatever numbers you're looking at, imagine there's like a tug of war, and this is their center point. Well, negative 2 and negative 3 are on the same team, on the same side of 0. So they're working together. And so you can imagine you would add the 2 and 3 together to get 5, but the answer would be negative because they're both on the same side of 0. So what happens if they're different signs? Negative 2 plus 3. Well, here's 3. Here's negative 2. If you think of it like the tug of war with your flag in the middle, they're now working against each other because they're different signs. So this actually, even though there's a plus sign here, the actual operation, the actual arithmetic is a subtraction problem. This is the same as take the bigger number minus the smaller number, you get 1. 3 minus 2 is 1. And because the bigger number was positive, it wins the tug of war. You could also visualize this as you have $3 and you lost $2. Well, your net amount of money is $1. If it was the other way around, where the negative number was the bigger number, and by bigger I mean bigger in size, not greater than, less than. Greater than, less than usually refers to the left of and to the right of. For example, 3 is greater than 2 because it's bigger. It's to the right of 2. Negative 5 is less than negative 4 because it's to the left of negative 4. But I'm not talking about that right now. I'm talking about just the size. Remember, every integer has a sign and a size. The sign is positive or negative, or it could be 0, right? And the size is also known as the magnitude or the absolute value, sometimes a word that we use. Basically, it's the distance that it is from 0. The size of the number negative 3 is 3. We might use a shorthand or use these vertical bars to represent the size of a number. But really what that means is just strip off a negative, and that's the distance that number is from 0. But anyway, you kind of see, well, if the bigger number is negative, it's still a subtraction problem. It's still 3 minus 2 if they're different signs, because they're still working against each other. You can imagine your negative 3 is here and your 2 is here. They're still on opposite sides of the 0, or opposite signs. So it's still a subtraction problem because they're working against each other. So your answer is still 1, but because your bigger number is negative, it wins the tug of war and your answer is negative. So that was a roundabout way of talking about the rules of addition. Basically, it amounts to, if they're the same sign, then you add, or add the sizes, keep the sign. Or if they're different signs, you subtract the sizes, larger minus smaller, and then the sign of your answer is the same as a larger number. That's it. So we can see now that there's addition problem. When you're using addition with integers, you could end up resulting in the actual operation being subtraction. So let's look at another quick couple examples. 15 plus negative 8. Well, that's the same as 15 minus 8. They're opposite signs. So you subtract the bigger number minus the smaller number, 15 minus 8, which is 7. And the bigger number is positive, so our answer is positive. So that's it. Negative 31 plus negative 11. By the way, these negatives that are written after a plus sign, you might see them written with parentheses around them just to distinguish them as separate numbers. This is still negative 31 plus negative 11. They're the same sign, so that means they're both working together on the same side in the tug of war. So you just add them together. It's 42. But since they're both negative, the answer is negative. Okay, well now let's look at subtraction. The cool thing about subtraction is it's just the opposite of addition. It's adding the opposite. In general, you might write it this way. If you're subtracting two numbers, a minus b, that's the same as adding the opposite of b. The opposite of b, or the negative. So initially, just to learn how subtraction works, it's always safe to just switch all your subtractions to adding the opposite. So for example, what if I got 10 minus 3? This is super easy. But you can look at it as, on the number line, starting at 10, and going 3 steps to the left, 1, 2, 3. That leaves you at 7, right? You can also look at it as adding the opposite of 3, 10 plus negative 3. Remember our rules, they're opposite signs, so you subtract them, 10 minus 3, and the bigger number is positive, so it wins the tug of war, so you get 7. Either way, you get 7. This seems like a long-winded way of saying 10 minus 3, right? But after a while, you'll be able to just kind of, in your head, just be able to switch back and forth between subtraction and adding the opposite. Sometimes it's more useful to think of things as adding the opposite. But let's look at another one that's similar to this. Negative 20 minus 10. Now you might see that minus sign and think, I got to subtract these two. 20 minus 10 is 10. We're done, right? Well, be careful, because that minus really is adding the opposite. So really this is negative 20 plus negative 10, and this is adding two negative numbers. They're the same sign. That means you're just adding the two numbers together. They're working together on the same side of the tug of war. Negative 30. So it might help to switch to adding the opposite. But the instances where this idea comes up really important is when you're subtracting a negative number. Let's look at 8 minus a negative 4. So let's rewrite this as adding the opposite. 8 minus negative 4. Adding the opposite just means we add the opposite of negative 4 is plus 4. So this is just 8 plus 4. So this is just a sneaky way of writing 8 plus 4. So if ever you see minus a negative, or minus a minus, immediately you can go, oh, that's just adding the opposite. A more complicated example might be if you've got a whole string of additions and subtractions, maybe. 10 minus 5 plus negative 4 minus negative 9 minus 11. So it might be useful here to just, especially if you've got a long string of things, to convert everything to addition. If you've got subtractions in there, convert those to addition. Definitely, regardless, I will convert this minus a negative 9 to adding a positive 9. And then I might as well write this as adding negative 11. Also do that with the minus 5 too, just to be consistent. And the reason you might do this is so that you can separate your positive things that you're adding together, the 10 and the 9, from your negative things that you're adding together. And you might just add those two sets of numbers together separately and then do one subtraction at the end. 10 plus 9 is 19. Negative 5 plus negative 4 is negative 9. And negative 11 plus negative 9 is negative 20. And now we just have, since we got a positive number and a negative number, we're just going to do one subtraction. This is 20 minus 19, or 1. But the bigger number is negative, so it's negative 1. So hopefully that makes addition and subtraction a little bit clearer. It may seem a little weird to do this with subtraction. Obviously, for easy stuff like negative 8 minus 3, you can kind of already tell that that's negative 11. You don't have to do the whole switching, adding a negative. But if you're ever not sure, rewrite it. Convert your minuses to adding the opposites. And it will become a lot clearer. If you know your addition rules, it'll be a lot clearer. It's real easy to get confused otherwise. So anyway, I hope that helps. I think that's enough for now. See you next time.